Hi guys, welcome to this new video about limits. So here we're going to compute the limit of some functions. We're going to start with the first one, which is the limit to the right of 3 of 1 over x minus 3, because x approaches 3 plus, so x will approach 3 from the right. So we're going to use limits notation to get this limit, so it's equal to 1 over, since x is approaching 3 plus, we're going to write 3 plus minus 3. It means we replaced the x by 3 plus, and you know that 3 plus minus 3 in limits notation is equal to 0 plus, because x is approaching 3 from the right, so it's greater than 3. It's really close to 3, so it gives 0, and since it's greater than 3, it gives a positive 0, so it's 0 plus. So this limit is equal to 1 over 0 plus. Now you have to keep in mind that any constant c over a 0 will give plus or negative infinity. If you divide any constant by a very small number, which is close to 0, you're going to find an infinite number, okay? So here we have 1 over 0 plus, 1 is positive, 0 plus is positive, so the result is infinity. Okay? Let's move to the next limit, which is the limit to the left of 2 minus 1 over x minus 2. So let's compute it. The first term is 2, which is constant, okay? So we're gonna keep this constant, 2 minus 1, and we replace the x by 2 minus. So 2 minus 2, and this 2 minus 2, it gives 0 minus. Okay? So this limit is equal to 2 minus 1 over 0 minus. The 1 over 0 minus is equal to negative infinity. Okay? So our limit is equal to 2 minus negative infinity, which is equal to 2 plus infinity, okay? The 2 minus signs here become a plus. Now, what is 2 plus infinity? You have to keep in mind also that any constant plus or minus infinity is equal to plus or minus infinity. The constant has no effect on infinity, okay? So we conclude that our 2 plus infinity here gives infinity. So our limit is infinity. Now, for the third one, we have the limit as x approaches negative infinity of x squared plus 1 over x. Again, here we're going to use the limits notation. So we're going to substitute x by negative infinity, so negative infinity squared plus 1 over negative infinity. Now, again, we will use this rule, guys. A constant over plus or negative infinity will give 0. It depends on the signs here of c and the infinity. You will find 0 plus or minus. But anyway, it's 0, okay? So let's compute. Negative infinity squared is infinity. A big number squared will give a big number, and the minus sign is cancelled with this square. So it's infinity plus, and we said that a constant over infinity is 0. So it's infinity plus 0, and infinity plus 0 gives infinity. Now, let's move to the next one. The limit as x approaches infinity of x squared minus 1 over 7 minus 2x plus 8x squared. Here we have a rational function. It's a polynomial over a polynomial, and it's a limit at infinity. In this case, you can use what we call the leading terms rule. It means that your limit here will be equal to the limit as x approaches infinity, and you just keep the leading terms in the numerator and in the denominator, okay? So the leading term in the numerator is the x squared. It means the term with the highest power. So x squared over And the leading term in the denominator is the term 8x squared, because it's the highest power in this polynomial function in the denominator. So over 8x squared. As you can see here, we can cancel the x squared in the numerator and in the denominator, and the result will be a constant equals 1 over 8. Okay? Keep in mind that you can use this leading terms rule only and only if you have a limit at infinity and you have a rational function. Okay? For the next one, again here we have a limit at infinity, or negative infinity in this case, of a rational function. So we're going to apply the leading terms rule, and it gives the limit as x approaches negative infinity of x, which is the leading term in the numerator, over 9x squared, which is the leading term in the denominator. Here we can simplify by x, we can cancel the x in the numerator and the denominator, and we will get the limit as x approaches negative infinity of 1 over 9x, which is equal to 1 over 9 times negative infinity is negative infinity. So we have 1 over negative infinity, which is 0. So your limit here is 0. Next one, the limit, again, at infinity of a rational function. Again, here we're gonna use the leading terms rule. So it's the limit as x approaches infinity of x to the power of 5 in the numerator, and the leading term in the denominator is x to the power of 4. Of course, here we can cancel the x to the power of 4 because it's a common factor. So we're gonna get the limit of x as x approaches infinity. And obviously, this limit is equal to infinity. Next one. Here we have a piecewise defined function, so we have to pay attention, okay? The first limit to compute is the limit as x approaches 0 plus of f of x. 0 plus, it means to the right of 0. It means that the x is greater than 0. And if you take a look on the expression of f of x, it means that you have to consider the second expression, because f of x is equal to 1 plus x squared if x is greater than 0. We said at 0 plus x is greater than 0, so we have to consider this expression, and it gives the limit of 1 plus x squared as x approaches 0 plus. So it's equal to 1 plus 0 plus squared, or 0, and 1 plus 0 is 1. So each time here you have to check which expression you have to consider to compute your limit. In the second one, the limit to the left of 0, 0 minus, it means that x is less than 0, and here we have to consider the first expression. So it's equal to the limit as x approaches 0 minus of 1 minus x squared. Again, here you replace your x by 0. Okay, it gives 1 minus 0, which means that it's equal to 1. Now, the next question is about the limit as x approaches 0. Here, we have already computed the one-sided limits at 0 plus and 0 minus, and they are equal. Since they are equal, the limits here at 0 exists, and it's equal to this common value, which is 1. Okay? Now, the question is about f of 0, not a limit, but the value of f at the point x equals 0. And as you can see here, we have less or equal. It means that you have to consider the first expression to compute your f of 0. So we compute f of 0 using the first expression here, 1 minus x squared. So at 0, it gives 1 minus 0 squared, which is 1. Now, the limit at infinity, and you know that when x approaches infinity, it means it's greater than 0. Of course, it's positive. So we have to consider the second expression. So it's the limit as x approaches infinity of 1 plus x squared. Of course, you can use the limits notation. So it's 1 plus infinity squared, and infinity squared is infinite. we're going to find 1 plus infinity, and 1 plus infinity is infinity. Okay? The limit at negative infinity, so you have to consider the first expression as the first expression is defined for x less or equal than 0 for negative numbers. So it's equal to the limit of 1 minus x squared as x approaches negative infinity. You replace your x by negative infinity, you will find that it's 1 plus negative infinity squared, and negative infinity squared is infinity, so you will find that it's equal to, sorry, it's not plus, it's minus here, sorry. Okay, so negative infinity squared is infinity, so it's equal to 1 minus infinity, and 1 minus infinity is negative infinity. Okay, thank you for your attention and see you in the next videos.